Hello everyone, this is Christopher and welcome to the solution video of the midterm exam of winter 2019. And in this video, I would like to go through the winter 2019 exam, and this is part of the midterm review of you guys for the database course. Okay, so on the left hand side, you can see there is a ER model and the corresponding relational model of this exam. And on the left hand side, I'm gonna point out some important details using highlights, and I might write out some solutions on the side. So let's get started. So just pay attention. This is the winter 2019 exam. Okay, don't mess up. Okay, so normally the first page of the actual exam comes with the background information. You do not have to read it very carefully to begin with. This is because it has a lot of useless information. For example, like blah 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 is a Montreal based dance studio. It doesn't matter actually. So usually when you are looking through the first paragraph, you just circle out some potential entities. For example, I might suspect, okay, this classes or instructors, those look like actual entities, right? Okay, so let's go on. Okay, so here for the first bullet point, a dance studio has many instructors, so I suspect that instructors might be an entity. And blah 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 blah, a lot of descriptions. You do not have to read those to begin with. And for the second point, the studio specializes in various dance forms. I guess dance here might be an entity. I'm not sure. Okay, let's go on. The studio provides sessions for different dance. Okay, I guess dance session should be an entity as well. Okay, a lot of description, blah 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 blah. Session. Okay, here we see that the instructor appears one more time. So let's go on. Okay, students definitely, right? That makes sense. Okay, blah 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 blah. Okay. That's the way you should read through the first page of the background information, because it's just a background information. So comparatively speaking, I feel like the ER model and the relational model are much more important. Okay, so this is the second page. You can see. So generally, we can tell that sessions here is a very important entity, right? Because it's the center of the graph, and each session has another entity of the lesson state. So we might suspect that maybe for each session there's various lessons, which makes sense, right? And for each session, maybe there is one instructor or more instructors associated with it. And maybe here maybe the session is to teach certain genre of dances, I don't know. And for each session, maybe we can have a registration of several students, right? Okay, so one thing to notice is that in the actual exam, the ER model and the relational model may not be reflecting exactly the same thing. So there might be something off. For example, Jane, right? Jane maybe has done something really bad. For example, she was translating this ER model into a relational model, so she might make some mistakes. So those were for the design of the question. So just do not take it for granted. Okay, so actually let's get started with the actual questions. So this video we are focusing on the multiple choice questions only, and I'm gonna separate other parts individually. So okay, so let's begin with our first question of the multiple choice. Okay, so So the multiple choice questions, like the wording is kind of like tricky because you have to pay attention whether, for example, in the first question, whether it's like based on the ER translation or something like that. As we can see later, maybe the questions are not based on the ER model. It can be like based on the description, or it can be based on the relation model as well. So that might like differ. So okay, which of the conclusions are correct? Choose three. So that is like exactly three answers. So A, there can be dance forms with no instructors with expertise in it. Okay, so let's refer back to the ER model on the left. We can see that there can be dance forms with no expertise in it. Yes, because here we do not have any like key constraint or participation constraint here. So A is correct. I'm gonna highlight A like that. Okay. So for B, there can be dance forms with no session for it. Okay. Um, yeah, this is also correct. Just to save time, I will not like go through every single options like very in details, because I feel like at this point of the time, you must be like very good at those questions actually. Okay, so let's see. Option C, an instructor cannot give a session for a dance form if that instructor is not an expert in that dance form. Actually, from the ER model, there is no such a constraint, right? Right, because right, there's like no such a constraint. We only see here like all the instructor for each instructor, he or she must be like good at in like at least one dance form, but there's no requirement that saying that the instructor cannot teach a dance session for which he or she is not very good at. So C is incorrect. Okay, now so option D, an instructor may not be an expert in any dance form. Oh, that's just what I said earlier, right? So this is false because we do have a constraint here. Okay, let's go on. A session cannot be created without at least one instructor assigned to it. So at this point, if you're like super confident that my option A and B are both correct, I just choose E instead because we know that C and D are incorrect, but we will go through this anyways. Okay, a session cannot be created without at least one instructor assigned to it. This is true, right? So we can see that we have a constraint right here. Although on the instructor side, we do not have like any constraint pointing to the session, but we do have a a participation constraint here saying that my session has to have at least one instructor to be created. Okay, so that is for question one. Let's go to question two. Again, this is based on the ER translation. That is the ER model over here. Which of the conclusions are correct? Also, we are going to choose three answers. Okay, so option A, the ER will not enforce that the start date of a session is its first lesson date. Okay, so let's check where is my lesson date? It's right here, my lesson date. So it is actually a common sense that my ER model usually cannot enforce a lot of like constraint or a lot of like auxiliary requirements in my design of my database. So that's the relational model actually. So basically there's like a few points that the operators or the users of the ER model have to pay attention. So yeah, no, the option A is correct. The ER will not enforce that the start date of the session is its first lesson date, because we can just actually see here like the start date, right? The start date of a session, it is just a partial key, since we know that my session is a weak entity. I'm sorry, I was just pointing to this lesson date. I was wrong. Okay, so this is actually start date we were talking about. So it is just a partial key. There's like no constraint saying that okay, so the first partial key of this session, it has to be like before any other dates of the session. It does not make sense. Okay, but actually this can be achieved when we are actually implementing this database with code. So we can check if my incoming data points or data entries are indeed like after my first start date. So this can actually be achieved during implementation, but we cannot tell this is like indeed enforced in our model. Okay, so let's go afterwards. So for option B, for lesson dates, weak entity set, lesson date can be used as a partial key instead of lesson number if a session has only one session on a given date. Okay, actually this makes sense. Why? Because here we can tell that my lesson date has like one partial key that is like the lesson number, and this is my attribute lesson date. Because like in real practice, it might be the case that one session that like actually we can have like multiple lessons during one day. But if we satisfy this assumption right here, we can just like remove the lesson number, because the lesson number here acts actually like a artificial key, right? Okay, so my B is correct. Let's go on. C, the ER by itself cannot restrict the capacity associated with a given session when students register. Okay, so this is actually an instance of the theory I just talked about, because here my ER model cannot enforce any restrictions right here, because we cannot say we're gonna store a capacity right here for which if the number of students pass is over this capacity, have to do something like that. No, we cannot do this for our ER model. The ER model is just it's just a diagram to illustrate the general structure of my database, how we should associate the tables. There's no constraint we can do about it. So normally if you during the exam and they see something we can use the ER model to restrict or to enforce or to have any constraints, actually it is highly possibly wrong. Sorry, using so many adverbs. Okay, so we know this is correct. Okay, at this point we can just we can actually skip the next two options, but we'll do it here for practice. Okay, so if we need to track the date on which a student registers for a session, it can be made an attribute of the student. That's interesting. Not really, right? Because actually we cannot enforce that a student can only register for only one course. So if for example, if a student registered for 2 sessions and he or she has only one attribute, the second time he or she register for the second course, or the second session, the previous value of this attribute is going to be replaced. So I do not see like the point of adding such a attribute like that. So no, this is incorrect. Okay, so for E, the model has no provision for a database application to analyze the popularity of the dance forms. Actually, this is incorrect because we indeed has ways to do this. For example, we can use our to start with my table of the students. Then I can like refer to sessions, and then I can access the dance table, right? So indeed, we do have ways to like analyze popularity of the dance forms. But so basically, we if we have access to the dance forms, we can like do some aggregation operations, right? So we can maybe like we set up a function or formula to calculate the popularity of the dance forms and sort them, right? So E is incorrect. Okay, so let's go to question 3. Okay, which of the following is true with respect to the relational model? So this is super important. Here we're talking about the relational model right here, right? So we are not talking about the graph here anymore. Okay, so how many correct answers do we have? We have 2 correct answers. This is different. Okay, just like be super careful. Okay, so let's start with option A. There can be instructors who do not have expertise in any dance form. Okay, so let's go to the expertise. So let's see instructors who does not have expertise in any. Right here, we can see in the relational model of expertise, we only have like D form, right? The D form references to dance, and the I name references the instructors. So there's like there's like also for instructors we can tell. Oh, there's like no instructors. Okay, so from this these 2 lines we can tell that we do not have to like require that every instructor does have a expertise, although that is like actually the case from the ER diagram, right? So we can see that there's indeed some discrepancies between those 2 like models. That's good to know. So I guess option A is correct. Okay, let's go to option B. A session may not have any instructor assigned. Okay, so as a common sense, we go to the sessions entity. Here, we have a D form and a start date. Yeah, there's like nothing associated with it, right? There's like no appearance of instructors. Also, we need to check this entity right here. This relationship here, we have the I name references to like those 3 keys are referenced back to instructors. But actually, this session instructor is describing the relationship here, right? So if I only have like 1 session over here, but we do not assign any, like we do not fill in the information of the relationship give right here, it is possible that a session can have a can not have a the instructor assigned. So it is possible, although this is not recommended if we were like implementing this database, right? So I'll say like option B is correct as well. Okay, so let's check option C. In lesson dates, the form should refer to dance. Okay, so this is a very common question. I guess like you guys have already encountered this in your assignment 1. So this is not correct because the D form here, D form along with the start dates right here, those like those should be composite. Those two should be referring back to sessions, right? Okay, so let's go to option D. Before we add a new dance form, we need to create a session for it to satisfy the referential integrity constraint. This is not a case because we need to create a session for it to satisfy the referential integrity constraint. No, because we know that a session is actually a weak entity of the dance, right? Of the dancing entity. So there's like no problem if we just create a new dance entity, a dance form right here with no weak entity or like no sessions attached to it. It's like completely fine. Okay, so registration will always have to be the last relation to be created in the database to enforce all the referential integrity constraint. Not necessarily. Actually, as long as the registration is not referred by other like tables, it is not the case right here. Okay. So for question 4, which of the following is true with respect to the relational model? Again, we are encountering the relational model that is to talking about this part, right? It is not a graph anymore. And how many correct answers we have? 3 to pick. Okay. Okay. So for option A, we need to join at the least 2 relations to find the last day of lessons for a given session with the form and start date now. Actually, this is not the case because we can actually do this in only one step. We can just like look for the table of lesson dates, and we can finish that in accessing one relation. So option A is incorrect. So for B, we need at least 3 relations to be joined to find the days on which a given instructor need to be in the studio for given lessons. This is incorrect as well, because we can actually access like 2 tables to achieve this. One is the lesson dates, and one is session instructors. Okay. So I'll leave the 3 correct answers to yourselves to practice because there's like those are not tricky at all. Okay, so let's go to question 5. In relation to algebra, we can find a start date for what? A dance form, sessions starting on or after blah 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 using the queries. Okay, we have like 2 correct answers. Okay, so we can actually approach these type of questions with elimination. So we are actually like for the final result, we want a start date for what, right? For what sessions? So number C, the option C here, we can tell there's like a no there's like no final projection involved. So usually this like type of solution is incorrect. Okay, so we can like eliminate C. So if we see and if we check option A, there's nothing associated with walls, right? Which is very weird because we at least need to like do a sort of like selection on the D form to select those watts. So, but there's like no sigma involved with watts. So option A is wrong as well. Very similarly, although in option D, we do see a selection with D form is equal to watts. The selection, okay, I see. This is very wrong because you can tell that the projection of the start date is outside like the selection of the dance form. So we're not like projecting any attribute of attribute of the second part right here. So actually this is like a orphan like here. So this is wrong as well. So the correct answer with our elimination, it should be D and E. Okay, so let's go to question 6. In relational algebra, we can find the email of students who have registered for both beginner and intermediate level watts using the queries. Okay, we also have like 2 correct answers. Okay. We also approach this question using elimination, right? Okay, so for option A, so for option A, since we know that we need to find students who have registered for the beginner watts and intermediate watts. So the formation here is very weird. This is saying that I'm gonna select the student who have registered for watts or whose level is either beginner or and the level is intermediate. This is like contradictory, right? This is very weird. Okay, so we know that option A is wrong. Okay, so let's look at option B. Like sessions and registration. We can tell that like B and C, the formation here is very similar, except for here one is a cap, one is a cup, right? So immediately we know that we cannot have anything like this because in like one session the level cannot be like beginner and intermediate at the same time, right? So like both of these expression is very wrong because you cannot like put like 2 conditions onto your level attribute at the same time, which and that is why we can tell that D and E are correct because we are like putting either of the level, either option of the level along with the watts selection right here. So those like selecting level is equal to beginner and the deform is watts is like a proper way to do this, right? So my answer will be D and E. So if you have like further doubts in terms of these two solutions, you can like post questions on discussion board where we can like further elaborate this. So okay, so for question 7, Assuming that the attributes in SQL tables directly correspond to the relational translation that we saw previously, we can find the names. So we're gonna find names of instructors, blah blah blah, with experience in ballroom. Okay, so we are like selecting SQL queries and choose 2 correct answers. Okay, so similarly, we are gonna like use our way of elimination. Okay, so because I knew the answer, so I'm gonna like start like in the other direction. So I'm gonna start with option E, and I'm gonna like tell why it is wrong, because okay, this is like very straightforward, because we know for either intersect or union, like the 2 parts from the left and right, those should be like compatible, right? But if we like see this correctly, we are gonna like select the instructor name on the left hand side and union all with what we selected that is like deformed from the entity. So basically we cannot like union a instructor name with a dance form. So my E is incorrect. And that is also the case for D. We are like intersecting instructor name with dance form. That is incorrect. Okay, so for number of so for option C, so what's wrong here? It looks like that here we are like selecting distinct instructor name from a combination right here, right? Like this looks good, but since we are like taking a product of like 2 tables, we have to make sure that the entries indeed match, right? So we have to say that I'm gonna like write this down here, sticky note here. Oopsie. Okay, we have to like make sure that my E dot dance form is indeed equal to the dance form here. And how can I move this? Jesus. Okay, that's good. Okay, so that's why C is like wrong. So my solution to this question should be A and B. Okay, so for the last question, this is like a calculation question. So normally this question is kind of long compared to like the previous questions in terms of its description. This is because we have a lot of like numbers in it, but do not panic, because normally this question is either very difficult, you cannot like do it like very quickly, or it's like super easy with for which you can find a very easy way to do this. Okay, I will put out a sticky note using highlight. Okay, so basically we have some information about all the attributes, like how large is it, and yeah, so the question. Okay, so one thing to pay attention is the fill rate. For example, if I have like 1 page, what is like fill rate? If the fill rate is like 50%, that is to say, normally I will only use up 50% of the room on this page to store my stuff, because we may need to prevent this like some like bad consequences in database operations. So that is like a routine practice. So what is the question? Okay, so suppose the average number of lessons per session was made to 60. what will be the total number of pages required to store the lesson? Okay, so after reading this question, I might go back to the description and to search for what information is like necessary to conquer this question. Okay, so let's go back to the description. We know that the form is stored as varchar 15 with an average length of 10. That is to say, the size of the form is 10. It's not 15. This is very important because it is explicitly stated that the average length is 10. Okay. Okay. So for both start date and lesson date, so those are like stored internally using 32-bit integers. That is 4 bytes, right? So just pay attention whether it is in bits or in bytes. Lesson number is stored as a small int. It is like 16 bits. That is like 2 bytes. Oopsie. I'm sorry. It should be 2 bytes like this. And the row header is 4 bytes. A character is 1 byte. Ignore slot overheads. Okay, so we see here a character is 1 byte. That is to say, here my deform. So the unit here, the average length of 10 bytes. So ignore the slot overheads. There are like 200 sessions. Blah 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 blah. Currently, we have like 80 pages. Okay, so actually, after reading all of these, some information are useless. Why? Because for this question, we're only like we're only calculating what is like the overall increase in the number of pages, right? So basically, we just like need to calculate the total size of all the data originally stored in our 80 pages, and then we can just like scale the pages accordingly. Okay, so I'm gonna put up a sticky note right here. Okay. Suppose the average number of lessons per session was made to 60. Okay, so it was originally 50, and now it is like made to 60, right? So we need to like augment our number of pages with a scale of 60 over 50, right? So that is like the coefficient of augmentation generally. So the most important information here is that currently the lesson dates relation has 80 pages. So originally we only have like 80 pages to store all the information, and it was like sufficient. Now what happens if we like scale it from 50 lessons per session to 60 lessons per session? We just multiply it. We just multiply the original number of pages by the augmentation coefficient, right, like this. Okay, so the result should be equal to 96, approximately like that. Okay, yeah, it's finished. Okay, so a lot of people would say, oh, this is like a very neat way to do this, because so like the normally you will need to like calculate what is the size of each data entry using all of these information. But actually, this question is kind of different. It's very special, and it makes sense, right? Because normally we do not like have time to ask you guys to like finish all of these if it was like in this like type of like setting. So when you were doing like the last question of the multiple choice question, which is like always like the some computation like this, just like think twice whether there's like a very like practical way to do this. Otherwise, you're gonna like calculate in a very long way, like the size of data entry and how many entries can you store in one page, and then you can use that information to calculate what is like the general, like the overall increase in the number of pages after the scaling. So yeah, that is all for the 8 multiple choice questions. So that is like the end of the part 1. And in the following sections, I'm gonna like separate the short answer questions and the later the calculations and the drawings, something like that. So okay, so if you have like any related questions or like related to this 2019 midterm exam, you can post onto the discussion panel, and I can like further elaborate them to you. Thank you.